mathematicians. We are now going to look at linear functions. A linear function is an equation of a line. So if you were to graph it, you would have a line. One way we're going to look at writing them is in standard form. Standard form is ax plus by equals c. So these values in front, the a and the b and the c, are numbers. Right? The a and the b and the c represent numbers. There are a few specifications though. The number in front of x has to be greater than or equal to 0. Okay, you can have no negatives in front of x. Similarly, a and b cannot both be 0 at the same time. Okay? So in order for this to work, in order for it to be linear in standard form, a and b cannot both be 0. So our examples. We want to decide, are these linear? So I'm going to see if I can write them in standard form. So I'm going to move some things around to get x and y on the same side. I can easily do that by moving this 2x over. How do you move a minus 2x? Add 2x. What you do on one side, must do to the other. My x must come first, so I'm going to put the positive or plus 2x out front, plus y equals 5. A is bigger than 0, and these two are not 0 at the same time. Do I have it in standard form? Yes. So is this linear? Yes. I can write it in standard form. So it is yes, linear. Let's try this one. What happens if I move x squared over? It'll be negative. So can I have that negative? No. Right. So if I move this, minus 3, I have y minus 3 equals x squared. Now if I want to move the y, minus y, minus y. Does this look like our standard form? It looks really close, but what do you see that's wrong with this that up here does not have? Right, an x squared. So because it has that exponent, can this be linear? No. I can't have any squareds up in my linear equation, so this one is not linear. Let's talk about intercepts. Okay. Intercepts are where the graphs cross the axes. So the x-intercept is where the graph crosses the x-axis. So for what value of x it crosses. At the x-intercept, the y value is always 0. Since it's on that axis, it cannot go up or down, so the y must be 0. The y-intercept is where the graph crosses the y-axis. Okay? And if you need to remember which one is, the side-to-side one is x, the up and down one is y. So the y-intercept is where the graph crosses the y-axis. So that means the x value has to be 0. It goes none right or left. It just goes up or down on this y-axis. So x-axis, since it does not go up and down at all, y is 0. Y-axis, since it doesn't go right or left at all, x is 0. We're going to graph these two by making a table. Again, I would recommend getting one of our variables alone. So I'll keep the y, and I'm going to move this. So minus 3x, what do I do on one side? Must do the other. Y equals negative 3x minus 1. So now when I make my table, I need to figure out a couple points. What do you want to start with? 0. What else? 1, negative 1. Okay, let's plot some of these. Plug 0 in. 0 times negative 3, 0. Minus 1, negative 1. Plug 1 in. Negative 3 times 1, minus 1, negative 4. Plug this one in. Negative 1 times negative 3, positive 3, minus 1. Let's go ahead and graph some of these. Zero, negative 1, 1, negative 4, and negative 1, 2. And we can connect these to form our line. Okay. So make a table, plot some points. Let's try this one. This one's interesting. There's no spot to plug in x, so let's pick some values. I have nowhere to plug in x, so y is negative 5. For one, if I plug in, I still have y equals negative 5. If I plug this one in, all I'm left with is negative 5 because there is nowhere to plug my x in. So for everything, y is negative 5. So if I plot these, 0, I go down to negative 5. What about if I go over to 1? Down to negative 5. And if I go over to negative 1, down to negative 5. My graph is a horizontal line side to side. If it is a y equals, it will be a side to side. So I pick some x values. Anytime I tried to plug them in, all I'm left with is y equals negative 5 each time. Plot the points and get our line. The last example I want to look at is graphing using intercepts. Okay. So first thing I'm going to do is figure out my intercepts. So x-intercept, which one equals 0 for an x-intercept? The opposite one equals 0. So for the x-intercept, y is going to equal 0. And then what about for the y-intercept? Which one equals 0 for the y-intercept? The opposite, or x. Okay. So I'm going to find each of those, and I'm going to then graph using those 2 points. So for the x-intercept, I'm going to plug 0 in for y. So I have 0 equals negative x minus 5. I need to solve for x, and since it's negative, I don't want it to be negative, so I'm going to move it over to this side. How do you get rid of a negative x? Plus x. What do I do on one side? Must do the other. X equals negative 5. So this is the point, x, or negative 5, 0. Let's try it for the y-intercept now. Since I'm finding the y-intercept, I'm going to plug 0 in for x. So y equals negative 0. There's no such thing as negative 0. It's just 0. Minus 5. 0 minus 5. Negative 5. So this is the point. X is 0. Y, negative 5. Plug 0 in for the right spot and solve. So now if I graph those 2 points, negative 5, 0 up and down, and then 0 and down. There are my 2 intercepts. I will connect them with a straight line, And there is my graph of my linear equation. Plug in 0 for the x-intercept for y, plug in 0 for x, find our 2 points, plot them, and solve. Nice job today, mathematicians.